Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so the first thing we should do is check the nth term test. So remember, with the nth term test, we are trying to find the limit of we are trying to find the limit of this. We are trying to find the limit of this as n tends to infinity. So as n tends to infinity, the numerator will act as well. It will act the same. The denominator, well, as n tends to infinity, you're adding on a tiny amount here, a negligible amount. So let's just concentrate on this. So as n tends to infinity, the denominator will just act as this thing here. It will just act as this thing here, as this thing here, n to the power of 3. So as n tends to infinity, well, let's tidy this up. It will be 1 over 2n. Uh, that would be 2.5. So that would be this. So as n tends to infinity, you can see that this whole thing here will head towards 0. So this whole thing here will head towards 0. If it heads towards, let's say, 3, then we can immediately conclude that this series will diverge. But because it heads towards 0, then we are still unsure. So we need to do something else. So we need to do something else. Well, that something else is the limit comparison test. We need to perform the limit comparison test. So remember, with the limit comparison test, it's saying that the thing that you're trying to investigate, this an here, the thing that you're trying to investigate, which is this thing here, you should compare it with something that you know about. You should compare it with something that you know about. So with the limit comparison test, the thing that you're trying to investigate, you should compare it with something that you know about. And then if the ratio of the two, as n heads towards infinity, is greater than 0, then you can conclude something about it. So the idea behind the limit comparison test is that you're trying to investigate something. You should compare it with something that you know about. Okay, so you're really trying to compute this an over bn as n heads towards infinity. So let's start again here. We are trying to investigate this series. As n heads towards infinity, the numerator will act as this. As n heads towards infinity, the denominator will act as this, because you're adding on a negligible amount. So you can pretty much ignore this 4. So as n heads towards infinity, this whole thing here will act as this. Well, if you tidy this up, it will give you this. So we are trying to investigate this. We should compare it with something that we know about. We actually know about this series. This series we know is going to converge, because this power here is greater than 1. Well, this thing here, you can imagine this as this, and then ignore this 2 here. Well, this thing here, you should by now be able to tell that this thing here will converge because of this power here. But we can push this half into here. So we can compare it. Well, we are trying to investigate this. We are going to compare it with this. You could alternatively just compare it to 1 over n to the power of 5 over 2. But you could also push it in here and then compare it to this. Well, anyway, let's start again. We are trying to investigate this series. We should compare it with something that we know about. We know that this is going to we know that this is going to definitely converge. We know this is going to converge. So with the limit comparison test, we are trying to investigate whether this series will converge or if it will diverge. We should compare it with something that we know about. We know about this. This is our bn here. This is our bn. This is our an. So we should now compute this thing here. We should compute this thing here. We should compute this thing here. Okay, so computing that thing, we will need an divided by bn. We will need an divided by bn. So we will need an divided by bn. So if you tidy this thing up, this whole thing here will then become this. Now, as n heads towards infinity, the limit of this whole thing here, if you think about it, it will be 1. So going back to here, we've just computed this value here. we've just computed this value here. Well, they're all the same, but here we just computed this value here, and it turns out to be 1. So going back to here, because this value here, our value here is 1. Well, 1 is not. Well, 1 doesn't equal infinity, so this is out. We just computed this value here, and it equals 1. Well, this thing here, number 2, requires it to be equal to 0. Well, this is not our case here. This is not our case here. Well, we just computed this value here, and it equals 1. Well, 1 here, the 1 here is greater than 0. So we should think about this scenario here. We should think about this scenario. Because we just computed this value here, and it equals 1. Well, 1 is bigger than 0. So this is our scenario. We can forget about this. We can forget about this. So looking at this, because this is our scenario, it's saying that it's saying that this thing and this thing, they both converge or they both diverge. Well, this thing here, our Bn here, we know this Bn here is going to converge. This Bn here is going to converge. Therefore, the thing that we're trying to investigate, this thing here, the thing that we're going to investigate will also converge. Because it's saying here, this thing here is saying, if this thing here converges, then the Am will also converge. If this thing here diverge, then Am will also diverge. That's what it's saying here. And then we know something about this. We know that this is going to converge. So if this converge, then this thing here must also converge. So basically, our series here will converge. Okay.